Okay, so let's talk the last part with the part 4 of the cost of production, chapter number 7. In this part, our main objective is to discuss the mathematical treatment of cost minimization. So as we know, the objective of a producer is to minimize the cost with the given inputs like a capital and labor. So if there are two inputs, capital and labor, the production function FKL, any production function, describes the maximum output that can be produced for every possible combination of inputs, writing the minor product of capital and labor like MPKL. So we can write it if we do the first derivative of MP that's greater than 0, and when we do the second derivative, then it's become a negative, less than 0 for capital as well as for labor as well. Now the cost minimization problem can be written as like we want to minimize the cost with the WL, wage, with the labor plus rate of use of capital into the capital. Now subject to the constraint that a fixed output Q0 be produced, and this is our production function. So we can set up a Lagrangian as we discuss that optimization is we use the same concept of optimization in the consumer theory. Now in the production theory we also discussing using the same. So we set a Lagrangian function. Phi is equal to this is our cost minimization minus lambda into production function. Now one thing which you note here that in consumer theory we take the utility function minus lambda into the budget or the available income, the budget constraint. We apply the constraint there, and then we find out the optimal combination of those two goods. Here we use it differently, but it's the same thing, and that's what we will discuss in the next duality of this concept. We call it as a duality of this concept. Either we take a one function or a one as one thing as a given, and then we apply the constraint in the production function type, or we can do the other way around as well. So we derivate this Lagrangian function with respect to k. We get this value equal to 0, and then we derivate this Lagrangian function with respect to L. We get this, and then we derivate this with respect to lambda. So we get this. So combine the first two conditions in this one, like first two are minus lambda mpk is equal to w minus lambda mpl. So when we rearrange we get the same thing, like mpk over r is equal to mpl over w, and this is the condition for cost minimization. We can rewrite the first two conditions to evaluate the Lagrangian multiplier as well. Like we can say here the lambda is equal to r over mpk or lambda is equal to w over mpl. So r over mpkl measures the additional input cost of producing an additional output of unit of output by increasing capital, and w over mpl the additional cost of using additional labor as an input. In both the cases, the Lagrangian multiplier is equal to the marginal cost of production. So we can write it here that write the isocont, this one, marginal rate of technical substitution. So it is going to be mpk into dk, that's change in the capital we are using, plus mpl into dl is equal to dq. That's a output. So rearranging, we can say dk over delta change in capital divided by change in labor is mrts, or you can say this is the slope of the isocont curve. We can say also that mpl over mpk is equal to w over r, which is this is the slope of the iso cost curve, and this is the slope of a isocont curve, and we know that they are tangent to that point, so it means that the slope at this point are same. The slope of sorry, the slope, it's not working. So this one is the slope of an isocont, and this is the slope of isocost, and by this way we can rearrange it as well, like MPL over W and MPK over R. So we discuss this there as well, and this very now, as I mentioned, the duality is duality in production and cost theory. So the dual problem asks what combination of K and L will let us produce the same output at a cost of C0. So we can apply Lagrangian. You see here the Lagrangian. We write it a production function minus mu into, this is our cost function, or cost. So when we derivate it the same way that what we did in the other case, and ultimately we get the same thing which we are saying here. So this is the same result as that is necessary condition for cost minimization. That's a necessary condition. So as I mentioned, duality works like this, that whether you use this way or the other way, you get the same answer. So here is an example of a Cobb-Douglas function. Cobb-Douglas function is a production function in which the exponentials are equal to, sum of the exponentials are equal to 1, where Q is the rate of output K and quantity of capital, and L is the quantity of labor, where A and beta and positive constants. So we see here that this is our production function. A is a technology what we are using here, K is a capital, and L is a labor, and alpha and beta are the exponents. So we assume that A is less than, alpha is less than 1 and beta is also less than, so that the firm has a decreasing minor product of labor and a capital. If alpha and beta is equal to 1, the firm has a constant return to scale. So in this this beta, if it is less than 1, both are less than 1, then it is decreasing minor product, and if it is equal to 1, that's a constant return to scale, and if it is greater than 1, then it is increasing return to scale. So return to scale we already discussed in chapter number 6. So here we apply the same concept what we discussed, Lagrangian. We set a Lagrangian function with the cost function minus lambda into production function, and we derivate. When we derivate, we get these values with the derivation, and then we solve for L out of this. That L is beta R over alpha W into K. So then again we can find out is the expansion path. Now use equation to substitute L in the equation. So we so by this way we applying the mathematics to find out the values of L and K. So this is L, and this is the factor demand for capital, and this one, the total cost of producing an output Q, can be obtained by substituting equation for L into the equation CWL plus RK. So we see here this is our overall and some algebraic manipulation we can find out this is our cost function. The cost function tell us how the total cost of production increase as the level of output Q increases, and how cost change as input prices change. So when alpha and beta equals 1, so equation simplify. The firm's cost function contains many desirable features. To appreciate the fact, consider the special constant return to scale cost. Suppose that we wish to produce Q0, the output are faced by a doubling of the wages. How should we expect our cost to change? New costs are given by this production function. If a firm suddenly had to pay more for labor, it will substitute away from labor and employ more of the relatively cheaper capital, so thereby keeping the increase in total cost in check. So this is Cobb-Douglas function is just for understanding the whole idea. If and these duality and margin rate and cost minimization. So main idea you have to learn from there is that how we can minimize the cost. So we have to set the Lagrangian function, and then we derivate with respect to k, l, and lambda, and then find out the solution, how much quantity of labor we should use and how much quantity of capital we should use given the rate of capital as well as the wage rate. That gives us a level of output what we desire with a minimum cost. So this way we finish this chapter. We cover the whole idea of this chapter, and this is important from this perspective that in chapter number 5, chapter number 4, we learn utility maximization, and in chapter number 7 we are learning cost minimization, but we are applying the same technique of optimization. So this way we finish it, and thank you very much, and I hope you enjoy it, and if, thank you, bye bye.